My name's Evan. If y'all been here before, you'll recognize me. They asked me to do this, and I like to do it, so I do it. But I'm here to kind of MC. So I want to give you all a bit of a breakdown about what we'll do today. We've got quite a few speakers. We've got at least 2 that will be talking today, all on AI topics. And then in between those 2 speakers, we're going to take a little break so that we can do my favorite part, the networking, where we'll get to meet each other, chat, scan each other's LinkedIn QR codes, all of that stuff, send each other messages. It'll be fun. It'll be fantastic. Trust me. Then we'll have our second speaker. And then after that, wouldn't you know, we get to do a little bit more networking. Like I said, that's my favorite part. So I squeeze it in as much as we can, right? So before we get going, I do want to tell you a little bit more about PMG just because, well, we've got these nice offices and we host this event and we feed fantastic food here as well and drinks. If you haven't gotten a drink, grab some of that. But selfishly, the reason we do this is because we are hiring, especially for folks who are interested in this field. So like I said, if you are interested in working here or expanding your understanding or being a speaker here, also, please reach out, chat to any of the people that you saw with your hands up. All right. I think that's it. So with that, I want to introduce our first speaker, coworker of mine, Jason Hartley, everybody.
Thank you. Whoa. Yes. Well, welcome. It's an honor and a pleasure to be here. Hopefully after I'm done talking, you will not have lost your interest in working here, if that was something you were thinking about earlier. I wanted to talk to you about something tonight that hopefully will be interesting to you, certainly interesting to me. I've never gotten to talk to a group of people like this about this topic. I've talked about it with my children and my wife and Uber drivers and waiters, people on the street, my dog. But now I have a captive audience. I'm excited to talk to you about this, and hopefully it will all make some sense. So I chose these words really carefully, personal and practical ethics, because so much of what's going on in the AI world is hyperbole, something very distant. We're either going to end the world, we're going to cure cancer, we're going to do all of these things, and it can be a little bit, I don't know, confusing as an individual to sort of figure out, well, what's my role here? What can I do? What's right? What's wrong? And that's really a personal question. So I'm not here to tell you how to think or really anything like that. Just trying to give you some tools and talk a little bit about how I've dealt with it myself in my role. And my role is I'm the head of media innovation and trust, which is basically what we're talking about, right? It's using technology to advance what we're doing, but doing it in a way that engenders trust. And that trust may be for us, you know, we are in advertising and we want consumers to feel that. We want the brands that we work with to feel that, but we also want our teams to feel that as well. So I take it really seriously when something like AI comes along and how it can sometimes collide with our values as a company. And so how do we harmonize those issues? And so I have a personal role myself. We have a role as a company. So it's really important for us, I think, to always be thinking about this when we go to work tomorrow or whenever the next time we think about using any of these tools. All right, so enough with the preamble. So we'll talk about the state of AI, which you probably all know quite a bit about. So hopefully there'll be something new here. If not, it's just validating your smart ideas and then developing your own personal ethics, sort of figuring out where do I fit in and how can I think about these topics in a way that feel authentic to myself. And then applying that, you know, how do you make that a part of your work life and your daily life and how you interact with people? And like me, Uber drivers, you know, I have a responsibility to talk about AI in a way with Uber drivers that, you know, most people don't think about. But at any rate, so starting with the state of AI. So this is a typically understated comment about what AI could be from Sundar Pichai at Google, that AI is more profound than fire or electricity. That seems to me to be potentially hyperbolic, but it is obviously a transforming technology. We wouldn't be here if it weren't for that. And it's something that we really do need to take seriously. And it brings me to mind of this way overdone thing here that came from Spider-Man. With great power comes great responsibility. You see this all over the place when you're talking about AI. And it's good, and I think it's something that we should think about, but it does create a situation where it's like, well, do you have responsibility? Do I have responsibility? Who's in charge of this? Who's going to make the right decisions? Is it me? Do I have enough power? Where do I fit in? And so I've made what I hope is a helpful plot here of the various responsibilities and powers that people have in the Spider-Man universe. So we have way up here is Spider-Man. He's got all the power and all the responsibility. So it's easy to know if you're Spider-Man, say you're Mark Zuckerberg, you have a lot of power, you have a lot of responsibility. But most of us kind of live in a different part, right? We're not here, we're in this maybe higher responsibility, but low power situation. So where does that leave us? What do we do? How do we navigate that? And I think that the easiest way to do that is just to say, you have great responsibility no matter how much power you have, especially when you're thinking about AI, which by its nature is something that, by its nature, it will spread, right? If you make decisions and it builds and builds and builds and it's learning and it's proliferating throughout an ecosystem, you sometimes don't know where it's going to end up, right? So just assume that your power is great and so that your responsibility is also great. So with that said, I mentioned earlier, I don't want to tell you how to think. I mean, ultimately, this has to be something that's personal to you. I think that there are people who would say, well, I believe in the free market. I think that that representation is really important. I think that fairness is important, and whatever it may be, and we all have our own personal views. But I think what's important for us to do is to sort of challenge our own views as much as possible. So you want to go out there and use the resources out there from a wide variety of resources. Now, for me personally, I've been working in data privacy for the last few years, and I found that the fair information practice principles have been a good baseline for me as I think about what to do about AI, because it's an evolving state. It changes so much. You know, can I have something that doesn't change all the time with it? Do I have a North Star? And so these fair information practice principles, so it's stuff like collection limitation. And collection limitation just says, just get the data that you need. Now you can see where that comes into conflict with AI, where it is, let's get as much data as we possibly can. Use limitation, I'm only going to use it in a narrowly defined way. Again, it's in conflict with AI because the power of it is because we got all that data and we have built these models, these large language models that can do so many things. We don't want to stifle our creativity. So these things don't necessarily apply, but they are helpful as we think about it. So you're sort of creating your own set of ethics based on different frameworks that are out there that have been these sort of traditional ways of looking at things, and then evolving with them along with time. So as you think about it, so again, you want to go and you want to look at the points of view about these sorts of topics from a wide variety of people, because if you're only seeking out information that sort of validates your own set of ethics or opinions, then they're not going to be worth that much, because so many of these things that we deal with, they have unintended consequences that are hard to think through. And you may not be thinking about them because it doesn't affect somebody like you. And so you want to make sure that you're listening to as many voices as possible so that you can be sure that whatever decisions you've made are purposeful and educated and, you know, based on something. And again, it may not change your mind, but just that effort of sort of challenging yourself, I think, is worthwhile. All right. So an example of how this can be difficult. So a few years ago, I think maybe 2 years ago, there was this big, there was a paper that was put out and it got a lot of attention throughout the industry. And the question was, are LLMs weird? And by that, it is Western, educated, industrialized, rich, and democratic. And what they did was they plotted out, much like I did with the Spider-Man characters, and they said, so cultural distance from the United States, correlation between GPT and humans. And as you can probably guess, the United States is right up there, right? So when we were thinking about how something correlates with a person, it was thinking about an American. So we know there's issues with representation within the data sets. For instance, 20% of Americans live in a rural environment, and very little of their data is actually in the large language models because they're not using technology in the same way, except for chemical use and water use, which is what the chemical companies who are into farming have collected. So at any rate, so they're not represented. So that feels like something that is an absolute, we've got to fix that, right? There should be representation. But there's another side to that. So there's an article written just a couple of months ago about what this person calls the representation paradox, which is basically, yes, it is good to be represented, but that data can be weaponized as well, right? So it could be misused. So that could be for profiling in many ways, right? It can be used to keep people out of auctions or whatever it may be. So you can imagine there's a flip side to almost everything we look at it. That's why it's so important to keep challenging your assumptions and keep looking for other people's opinions so that you can build a more, I don't know, you want to represent or have a representation of the world that reflects a lot of different views. So again, once you have your okay. Hello? Let's see if this mic's better. So at any rate, so you have to deal with these things, and the only way to be able to do it is to continue to educate yourself and listen to voices that are different than your own, as well as the ones that you support, the ones that you believe in. So it is complicated, and I think if I had more design skills, I'd turn this maybe into a bingo card, but basically there are all these topics: fairness, transparency, human dignity, privacy, safety, accountability, innovation, sustainability, collaboration, all of these things. This list could go on forever. The challenge for you is just to say, which of these things are most important to me? You know, you can stack rank them. You can just reflect on these. And so that when you're confronted with a situation where you have some control or some power to change something, you can say, well, this doesn't really feel right to me on the safety side. It doesn't feel like I'm being secure with a customer's data or whatever it may be. And so it allows you to have sort of an approach that isn't so confusing and so always changing and reflective of, and reactive. It's something that you can kind of set a heuristic for yourself where you're thinking about these things in advance and know exactly what's important to yourself, which requires a little bit of introspection, but I would imagine you've thought about these things a lot. So it's really just putting some order to it. And the good news is that there are so many resources. And by the way, all of these are linked. So these are all linked to these resources. So everywhere where you have one of these things, there's actually a link. We're going to try to get those to you at some point. But you can see there's just such a huge variety of people. I'm going to walk over here if I could, because just to engage with y'all as well. But you can see like these are basically general AI ethics. This is Future Privacy Forum. They're doing a lot of really interesting work. And they particularly are like a think tank and have an incredibly broad set of people thinking these things through. So you get a lot of different things here. But the ethical AI resources for artists. We have intelligence. We have the privacy community. The ANA Ethics Code of Marketing Best Practices, which was something that I took part in because I'm part of the ANA's Ethics Policy Committee. UNESCO. On and on and on. There are all of these different flavors of opinions about how to do AI the right way. And if you continue to look at these things, I think that it'll broaden your perspective and help you feel better about the decisions that you're making. So you've thought it through, you've played the game, you've sort of figured out, okay, well, these are the things that are important to me. I have my markers that I'm going to use. So then what do I do? The interesting thing is that there are tools out there that can actually do this for you. You know, there are on GitHub, there's a lot of different resources, but there's this trusted AI conglomeration of a bunch of different options. This is Verify ML. They have a bunch of resources about using tools to be able to just, you apply them to tell you, is there bias? Is there, whatever it may be. IBM has something called the AI Fairness 360, which is something that has really, that seems to be really well respected. And Google has one as well, but there are a lot of different resources on these as well. So you can go through these things and say, okay, well, here's a quick way for me to apply my own personal ethics to some product or service or whatever it is that I'm working on. And I can say, I can evaluate it in a way that will reflect my values. And then if there's an issue, then you can raise your hand based on something that's more concrete than just, this makes me feel bad. But even when you use tools, obviously, we still need our own judgment. They really do. The tools are great, but you have to kind of run them. People in the AI community always talk about keeping a human in the loop. This is one of those times where it's really important, because you do have to sit there and ask yourself questions. What is the purpose and impact of whatever it is that I'm working on? Is there a social impact? Do users have control? Who's accountable? And what are the less obvious consequences, which is one of the big things that you always have to think through, because it's not always obvious. But that's really just you being a human thinking about these things and then applying those tools to help you be able to sort of maybe do it a little more quickly, and again, with more evidence. So here's a real world example just to close out. In the Spider-Man world, I'm basically J. Jonah Jameson. He's the one who he runs the newspaper. So he has a bit of a voice. I do a lot of these things. I have to write a lot. I do thought leadership, and I had a big team and all that sort of thing. So I have a little bit more power, a little bit more responsibility, and it's broadcast. So when I was thinking about, our embracing of generative AI here, one of the things that we have said as a company is that we believe that sustainability and thinking about the Earth is a worthwhile pursuit. And LLMs use a lot of energy, and this is something ethically, this is a real challenge. We have to at least be aware of it, right? So when I was thinking about this, I raised my hand and I said, well, are we thinking about this? Now, we actually have a group here that is focused on sustainability. And so I talked to them and they're like, well, this is great. We're actually getting ready to give everybody an AI license. So everyone's getting an open AI license. And we have some education sessions. In the very first session, I got to do the very first one, and it was about how to use this responsibly when you're thinking about ecological sustainability. So I raised my hand. I have a company that supports it. There was a group already in place, and I had a venue, so I used them. And so this is just a little taste of what I presented, but it's basically saying, all right, well, let's be factual here. Let's let everybody know that it's rough, right? 120 average American homes, training a model like GPT-3 for is an annual energy consumption of 120 American homes. And as we all know, there's not just one of these models going on. They're constantly being built, and they're getting bigger and bigger and bigger, right? So it's an alarming stat. This was particularly important because we have a lot of people who are search experts. And so it says, a typical Google search uses 0.3 watt hours of electricity versus 2.9 watt hours for a ChatGPT request, right? So a lot of energy is going into that, even to those sorts of things. But I don't want to scare people. I tend to try to be optimistic and just, when we look around, there's lots of ways that we're dealing with this problem as an industry. There are, and I tried to find the people with the least stakes in here, right? So MIT News is not going to hype up some solution, like they're reporting on it. And so all of these things are just saying, we're getting more out of smaller models. We're getting smarter about how we do the big models. We're learning how to do this more sustainably, et cetera. And so there's a lot of reasons to believe, but it doesn't get us off the hook. And this is something that was from 2010 that I have never forgotten. And it is, how bad for the environment can throwing away one plastic bottle be? 30 million people wonder. So this is just somebody who's like, well, maybe I'll just throw it in the trash instead of put it in a recycling bin, which seems very logical at the time. But if you think about how big the country is and all of the people using AI, like we all have to make good individual decisions. And that goes for our company as well. I wanted to show that there's optimism, but I did want people to realize that, we're 1,000 people, and we're using this a lot, and we're getting ready to hand you this. So just know this, and let's give you some things that you can do to make sure that you're using it the right way. So there were things that people like you probably know a lot about. Just these are things that applied generally, right? So avoid frequent redundant queries, make a plan. Don't just kind of use it and use it just to see what happens. Like, have a plan. Don't use it for simple tasks. This goes so in general. A lot of people gravitate directly to AI when something could have been, you could have just used good old-fashioned code. What's that? Yes. All right. Okay. And scheduling tasks for AI interactions. So scheduling is something that we can do maybe we do it at night or wherever when there's less power load and so on. Streamlining use, and I use this image made by AI, which I admit that I could have gotten probably from the internet, but it makes the point we're talking about AI. But you don't need an elephant to crush a peanut, right? And that's the sort of thinking that I wanted people to remember, right? So that they're doing it the right way. So everybody was empowered to do the right thing. And this is something that I thought was really important. And this was the way that I raised my hand, stopped the factory floor for a minute and said, let's think about this. And everybody agreed, and then we put it out there. So wrapping up. So everyone can and should play a role in promoting the ethical use of AI. Now, ethical is up to you to decide. It's totally up to you. Just make sure that you're thoughtful about what you define as ethical. Your beliefs are going to be strengthened by challenging them. There's nothing like going through reading a bunch of people who don't agree with you and walking away saying, they're wrong. I really still feel like I'm right, But it also feels good to say, God, I was actually wrong. I wasn't thinking about this. And now I'm smarter about this and I can make better decisions. And then there are tools to help for sure. So there are many practical ways to do this. And you can do it in a way that will help you do your job. It won't necessarily be destructive. It won't be disruptive, and it won't, hurt innovation, but it will help you. But you still, as a person, will always have that responsibility to make the good decisions. So I'll leave you with this quote. This also may be a cliche by right now, but I did like it. So the best time to plant a tree is 20 years ago. The second best time is now. And I think that if you're just thinking about these things today, and you're thinking, gosh, there was something that I wish I would have done differently before, it's fine. Just, this is the time, right? We are very early on in this game. So AI is pretty new, this version that we're talking about particularly. And so it's going to evolve, and it's going to take a lot. And we also are going to have to plant seeds that we may never get the benefit from. And we may need to be planting ethical seeds in the products that we're building that maybe don't benefit us and maybe actually cause us some harm or at least some discomfort. But it is important to do because we are planting this forest, right? And so right now is the time to do it. I'm so glad that you're here, and I hope that if any of this resonated with you, clicks with you at all. If it makes you do things a little bit differently tomorrow, then that's great. Again, though, if I said things that you already believed, hopefully that's validating. And if you totally disagree with me, at least you heard me out. So thank you. That's all I've got for tonight, unless we have questions. Glad to have questions. Yeah. Should I? Do we have two working mics or?
We do, yeah. But before we do that, Jason Hartley, everybody, please. Thank you, Jason. Appreciate that content. Our next speaker, Rabimba, who is a Google developer expert, and he's going to talk to us about rapid prototyping. Everybody welcome Rabimba.
Thank you for the introduction, and hi, welcome. And I want to talk to you today about a little bit different things. Kind of, we are not gonna go into AI, machine learning. We're gonna talk only about LLM, and why I don't call LLM AI, we'll come to that later. So before we start, I'm gonna do a little bit of coding today to show how you can actually start working with some of these, maybe work with your own data and in a private way. Before I start, I just wanted to kind of have a feel of the room. How many of you have played with some kind of GPT? Be that be ChatGPT or anything? Awesome. So everyone, how many of you have tried to run something on your own computer? Pretty good number. So how many of you have thought that, okay, if I want to run it on my own computer, can we run it in our own data, own PDF, own HTML file, something of our own? Can we train on ourselves? How many of you have tried or just like played with it? Awesome. So with that, I'm going to start my talk today. So we are going to start looking into that, how you can do some of this rapid prototyping on your own data, some of the ideas you have been playing with on your own, any kind of open source LLMs. I'm going to focus on Google's Gemma, but this is applicable, whatever we see today is applicable for all of the open source models. A little bit about myself. That's me. That's my friend. I'm Rabimbo. I'm a PhD candidate. I am also a Google developer expert in AI and machine learning, also web. And I'm a Google Cloud Champions Innovator in AI ML and also a research innovator. So without further ado, Gemma. Anyone, how many of you have heard about Gemma? How many of you know how many types of Gemmas are available? Okay, couple of them. So introducing Gemma. Gemma is Google's open source model built on the same kind of technology that's Google's professional Gemini model is built on, but this is open source, so the weights are open. In LLMs, if you have the weights available to you, you can run your own transformer model, and that can do the prediction, token prediction, just like any other LLMs, any other GPTs. So all the open source of LLMs we have, I would say just open LLMs we have, what you essentially have, you have the weights. Those weights are available to you to kind of tinker with, use them as you want, or kind of fine tune on top of that. Most of us are not in a position to kind of train our own LLMs because of the huge cost associated with it, but we can definitely fine tune them on our own data to have very similar performance. So at a glance, Gemma is a family of lightweight models. Each of the models we have are suited for a very different tasks. So some of the things, if you play with Gemma, you will see that the first part is a double-edged sword. So responsible by design is that these models are not your uncensored models. So when you play with it, if you have very specific kind of data, it might not answer you. How many of you here work with biomedical data? Awesome. Because if you would have, there are certain kind of advices, certain kind of questions you might have asked, which Gemma would have told you we cannot answer. And that you have to do in a very defined way. There are models, Gemma models, which have been fine-tuned for those tasks, which you have to look for, which we are not going to go for today. So the performance is very crucial because we have certain different parameter-based models, which are interesting for different use cases. For example, the 2 billion parameter model, as we will see, can run directly on your laptop or even your mobile phones, which is awesome, but it's not that smart. If you want something really to solve complex problems, by complex problems, maybe reasoning problem, maybe a question you have, you might go for a bigger model. Whenever we talk about models, we need to know for our usual task how they perform. Can they perform what we want it to do? So for that, benchmarking is important. They tell us each of the models' strength and weakness. All of the models have their own strength and weakness. This is just an example where how Gemma performs compared to Llama 2 and Mistral 7B. This is an old slide. Llama 3.1 was introduced just today. So you probably, if you run this, you will see Llama 3.1 beating Gemma handily. So just running it and playing with it is not probably going to be enough. Today, we also want to see if you want to kind of prototype it for your own customer, maybe, or a proof of concept, how you can productionize it. Can you run it in your own existing cloud premises? Can you run it using your own machine learning ops? Like, can you run it using your own ML ops platform? Can you productionize it, use your existing infrastructure for it? So we're also going to see how to do that maybe in cloud, specifically if you want to use something like GCP or AWS. So before we delve into, this is kind of like a very small glimpse of if you want to use Google Cloud Platform in Vertex AI, these are different kind of models which are available part of Model Garden. Almost all the cloud providers right now have something similar. If you go to Azure, Azure has Azure's own way of kind of exposing different models, different open source and as well as proprietary models. AWS has the same. If you look at GCP, you will see some of the ones are proprietary ones, but then you already have the open source models, which you can just pick and choose and deploy. But if you want to deploy, what do we mean? So let's look at what we want to do with your models. What does your customer want? So why do you want to use something like Gemma or Llama or any kind of open source model instead of something like GPT, something like Gemini, something like any proprietary model. So that comes into play whenever you have a data that cannot go out of your premises, maybe medical data, maybe some kind of proprietary data. If it cannot go out of your premises, even with vendor agreements, you might want to run your own LLMs on your own infrastructure or even in cloud within your own premise. So to do that, you have to kind of evaluate what you need, and only then you kind of like can define which model and where you want to use, where if you want even an open source model, because there is a cost associated with running them. Now, what we kind of looked at, so open LLM and commercial third-party hosted LLMs. As we have already kind of seen, there is always a little bit of gap between commercially available LLM APIs, for example, GPT-4, 4.0, Gemini 1.5, Claude, all of them, how their performance is, and the state of the art of open source models like Llama 3, Llama 3.1. So there is always, even though if it's small, there is always a gap. So the question might be why you want to use open source model, or if you want to use them at all. So one of the easiest ways to look at if you are hitting a legal and compliance problem with that. If your data is something which cannot be used with the commercial LLMs terms and conditions, for example, even with anonymized options, your data cannot be used for training, which most of these LLMs do, then you might want to use something of your own. Open LLMs kind of allow you to run your own LLM, doesn't matter which model, in your own tenant, within your own rules. Some of the easy, like some of the open ones available is Mistral AI, Gemma, Llama 2. And whatever we are going to see today, how you want to train it, how you want to do it, is applicable to all of them, not only these. So when I say all of them, this is a very small kind of picture of how many codes, how many like open source LLMs available, not open source only. So these are kind of like the huge, huge scene we are at, different LLMs, different kind of performance, and from different companies, each excelling in very specific things or multiple things at once. So how many here are developers or works with code in their day-to-day life? The next part is specifically for you. So let's look at the developer walkthrough experience if you want to build something. Let's see if you want to do it, play something with one of the open source models, how you do it. So I have 3 Google Colabs right here. So Colabs let us run Python code using free GPUs in cloud. Might not be the most powerful one, but good enough for most of our use cases. I'll just go through 3 of these demos. Actually, I'll go through only one. The rest of them I'll just show you in the interest of time. And each of them will show kind of one like capability of a open source LLM and how you can play with it. So the first one, guess the word, is essentially, let me click on it, is essentially this collab. Okay. So let me run it first, and then I'll go through code by code what's happening. So I'm gonna run Gemma model here. So first I'm gonna give my Kaggle username and password because I want to get the model from Kaggle. And then I'm just gonna install Keras and here. So this is the model I want to kind of play with. So this is a very small model. This is a Gemma's 2 billion instruction model. This was the second version of it, 1.1. I know the nomenclature is misleading a little bit. So this is a very small model. Technically, this is not as powerful as something like Llama 7B, even Gemma 7B. So yeah, but we'll see. I specifically chose that to see that what you can do even with this. And then I can show you how you can run it in your own mobile right now. Let's see where we are. Okay, so we are downloading the models. We're getting the models here. So what we are trying to do here is that we're gonna do a like word guessing game, and let me make it bigger so that you all can guess with me, because I'm very bad at it. I literally lost the game while I was trying to do the demo just before the talk. Okay, so in a word guessing game, so this is essentially the code. We choose a theme, it generates a random word, Gemma 2 generates a random word, we try to describe that word, and if we are correct, so let's start with technology. I'm pretty sure I'm again gonna fail. Okay, our theme is technology, and you all can read, right? Okay. It is running, right? Yes.
It's very bold to do a lot of demo.
Oh, I always do it, and I always kind of, right now is the time I'm praying that, okay, let it work, let it work. I do have backup in case it doesn't work. While we are waiting for it. Oh, just nick of time. So XXXCT encompass a wide range of concepts from the creation of physical objects and systems to the manipulation of physical process. Anybody has any idea what this is? What? Let me, XXCT encompass a wide. Okay, I'll start inputting whatever you guys say. So give me a word, something. Like, what? Gravity, okay. Let's try. We're gonna try this maybe 3 or 4 times if we cannot get it. No. Okay, creation of physical objects and system, manipulation of physical process, generation of information, simulation of human cognitive functions. Okay, yeah, that might be. No. No. So not to keep on going, let's see the answer, and then we can go to like a different theme. How? Okay, not a nice example. We will also see how we stop hallucination on the next collab. Okay, so as we saw in our awesome example that how AI works and how AI can hallucinate things which we don't want. Now, the most natural question most of you have is that, okay, this is nice, fun and game, which failed it. But if we want to run it on our own data, how we can do it? I have a demo for PDF, which is most interesting, but not even going to PDF. If you want to do it with a web page, for example, this web page. This, if I open it, this is introduction to Gemma, this HTML page, it has a lot of text and images, etc. So what we will try to do here is something we call retrieval augmented generation. How many of you are familiar with the term? I guess almost everybody. Yes, okay, a lot. Still, so what RAG allows us to do is that Essentially, the concept is just that we take our own data, pass it to the LLM, and ask it questions on that. Going a little bit deeper, this we can literally copy paste and send it, right? Then why don't we do that? That's the in-context way of doing it. If you have a lot of data, that pushes your context window of the LLM very fast. By context window is in one prompt, how big the data the LLM can parse through, which we don't want to, because if it cannot pass through our whole data set, it will start missing things. So for example, if you want to run your LLM to generate code or review code on your whole company's data set, you cannot do it. So what you can do is that you build a small RAG pipeline. What essentially it does is that it creates a vector database of all the text you have. So for example, right now what we did, we just took it and the web page and took all the text out. So this is all the text out. Then we are going to install something called ChromaDB. You don't have to use ChromaDB. This is a vector database. There are a lot of them out there, Pinecone, and a lot of them, which it failed. I probably. So what we want to create is that we take all the text and we pass it to a vector database. What a vector database does is it creates a database based on the words, which will be our token, and what is the nearest word to that. So based on the semantic distance from that word. And once we have it, based on our question, whatever we get from that database, we pass only that portion to the LLM to get our answer. Let's see where we are failing. Okay. Now I'm getting more interesting errors. Okay, I think my demo time is almost over. Okay, so we saw how we did that. But one of the things we just talked about is that the context length, right? So each of the GPTs has a specific context length, and out of that, it cannot work on that. So we go for these kind of like tricks, like retrieval augmented generation, to bypass that. But that's not a good solution. Gemini 1.5 has a 1.5 million context window where you can pass a lot of things without going for retrieval augmented generation and work on that. It also has a 2 million context window, which is under preview, which I can show. But those are all commercial models. If we want to do it on Gemma or open source models, what do we do? This collab, I'm not going to run it. Works. Okay. So what this one does is that it uses a concept from a paper called self-extend, and there are multiple papers right now which kind of does different tricks to do that. We say extend the context window of Gemma to 10,000, which is almost 5 times the original context window of the LLM. With that, once you have the context window extended, you can pass a huge number of text without going for a tricks like retrieval augmented generation. Now, that's all fun and good, but that's only for text. Remember what I said, what if you're working with biomedical data, or if you're working with any kind of data, maybe image data, the traffic lights, something like that. So remember when we talked that Gemma has multiple models? One of them is called PalyGemma. So PalyGemma is a mixed multimodal model, or more specifically, this is a vision model. One of the other open source vision models is called Lava, which is built on Llama 2, and on top there is a clip vision encoder added to that. That's another open source vision model. But this is a vision model. What a vision model does is that For example, I am not gonna run it, but I should have the results here. What we did was that we tried to caption scientific images. For example, these. What does it mean? So if we try to generate caption out of those and see, it should eventually give you something like this. Okay. Shows the difference between standard MA, Huber logistics, caption the figure. If you want to caption the figure, it shows what it is. So these are the things you can do with a vision model. You can ask it to parse images. You can ask it to kind of know knowledge understanding, specifically if you are not working only with textual data. Okay, now we can go forward. So if you want to kind of play with it outside Colab, you can play with it directly in Vertex AI. So this is what we essentially did. There are multiple adapters you can use or libraries you can use to play with it. So I used Keras for the demos. And then you have JAX models available, like JAX adapters available. If you want to run it directly on Vertex, then you can, like, if you are in Hugging Face, once you click on deploy, you should see something like this Google platform. It will directly redirect you to the Vertex model garden. If you want to do it from Kaggle, it also has the similar way. Once you are in GCP, it's as easy as just clicking the deploy, and it will create the whole model deployed in a GCP instance and playable for you. So this is like two-step sign-in for cloud customer, and you can work on Vertex AI. But if you don't want to do it inside Vertex AI, want to run it your own managed Kubernetes cluster or engine, so this is the Kubernetes ecosystem. You can also run it inside that. One of the other benefits is that you can also run on your own specific hardware requirements based on maybe you want to fine tune it or you want to do very heavy lifting, you can run it on TPUs. So this is how it kind of looks like. You just deploy on the right side. You're given that, okay, which model you want to run and the whole template. If you want to play with it, but not in public Colab, you can also run it in cloud notebooks. This is how it looks like inside your own premises. The flexibility it allows you is mostly using different kind of platforms. So for example, VLLM is right now one of the very popular serving solutions, which can run multiple open source LLMs, and you can very quickly integrate that part of your infrastructure at the moment. If you are too much integrated into NVIDIA's ecosystem, you can also run NVIDIA's TensorRT LLM framework inside that. So this can run, this is not only for Gemma, almost everything that's available in Model Garden can be run in any of these. Most of the models which are available in Hugging Face can also be run like this. This is how right now the whole situation looks like. If you have tools and libraries, you have frameworks, and then you have the infrastructure part where you might want to run it. Now, the resources which I kind of talked about today in the talk is if you want to learn more about Gemma or any of the LLM infrastructure or coding, this is kind of like the resources you might want to take a look at. So this goes to some of the examples I showed, all the technical reports, and also the documentation. Without talking about specifically Gemma, if you want to kind of see if you want to use LLM or not, this is kind of the decision tree I want you to kind of have a look at. Do you need a LLM? If you need a LLM, do you need an open source LLM? If you kind of go through the decision tree, try to answer them, this might answer based on what you need. If you need a commercial one or if you need an open source one. With that, I'm open to any question and answer. And also, I would encourage you to please fill up this survey form so we might know better that what you liked, what you didn't like, and so on. Thank you for, thank you for attending my talk. If you want to get in touch with me, these are my socials, and I'm happy to take any questions you might have. Thank you.
Hey, hi. I have some basic questions. I'm not any expert on RAG or anything, but so in RAG, you mentioned about a semantic search, right? The proximity search. So if I have a 10-page PDF, right, and I want to summarize it, there is no semantic search over. It has to read through the entire document. So how does it work in that case?
So summarize is not, so RAG is mostly useful if you want to do a question answering or something like that, right? So summarize, you need the whole thing. So that way RAG is not useful in that case at all. So either you have to pass the whole thing or extend the context or go for partial summarization that, okay, chunk it out, summarize them, stitch it together, summarize the whole thing. That degrades the performance a lot. So I would more like, I would say either go for a model which has a huger context or extend the context.
Okay. One more question. So regarding the running the model locally, what's the capacity that we should have on the machines? Like would give us some approximate.
Thank you for asking that, because I wanted to show you a demo which I forgot. So you can actually right now in your own, this probably will work in mobile. If you have a Chrome and if the Chrome has a, is after version 113, which all of your Chrome should be, then, so this web page, this model will run directly in my machine without running in server. So what happens is that the first time I do, it downloads the whole model, caches it, and then uses my own GPU to run it. The beauty of this is that it's running in browser using web GPU. So essentially, I'm in Zoom, but otherwise I could have just shown you that I disconnect from internet and it can still answer the question and go around. So right now it's not using my discrete, it's using my like integrated GPU. So actually, I can still show you something. So this kind of answers you like what kind of machine you want. So let us look at the network. So if something is going away. Okay, that's not how it's supposed to work. Let me try again. So essentially, once I load it, since I have already loaded it, it should not send anything. And now, okay. So coming back to your question. So right now, this is running in my Intel CPU, but you can play with it in your mobile and it will run in mobile. So I have played with it in Pixel 2 XL and it runs there. So you can kind of see where it's very bad, but in my 8, it runs pretty fast. So that's kind of gives you how much you want. But this is very specifically for a very lightweight. This is a 2V model. So yeah.
As you've expanded your RAG context, have you found any issues with the lost in the middle problem where as your context get bigger, it ignores part of it?
So there are different ways to extend the context. So what, we'll come back to the song. So which one did I use? Yeah. Okay, so there are multiple ways to do that. The one I did was I implemented part of what they did. So in this one, if you look at the result, you will see they did the middle of a haystack kind of experimentation. Where was that graph? Okay, so look at the right one. For Mistral, at least, so they didn't play with the Gemma. We did it later. So they implemented it in Mistral, but if you see in Mistral, they didn't find anything bad. But this is a paper, of course, you will see only the good results. But there are misses, very few. So there are multiple ways right now to do that. So this is one. Then there is this one, which I did not do because this is. So there are different ways to do that based on what works for your model and specifically your data. We now have an option to kind of go for different ways. So yes, that kind of where we are. It mostly does not miss. I have played with it. I have informal, like I can say you informally, I missed maybe once in all my tests, and I ran like a 10,000 test for different small context, but just to see that if it can find like a needle of haystack benchmarks. So yeah. Yeah. Yeah, I mean, if you look at the paper, they don't leave any context behind, but they don't talk about finding them.
All right, any last questions? All right, everybody thank Rabimba for his help and his
Thank
speech.
you.
Before we get going, I want to make one more pitch. I talked to quite a few people during our little break who are interested in speaking. If you are interested in speaking, find me, talk to me. We have a form that we can send to you, and we need everybody with any expertise. We've got quite an array of experience in the crowd, and people love to hear about anything that you talk about. So if you're not super technical, you don't have to be. If you like to speak on compliance and best practices, we want people who can talk to that. So reach out to me, let me know, and we'll get you that form and we'll get you ready to go. All right. I'm done with that. Okay, let me welcome our last speaker, another PMGer. Everybody welcome Brent Schneeman to talk about the impossible intern.
Thanks, Evan. Yeah, I am Brent. Well, my last name is basically unpronounceable, so I'm not going to try it. Just want to reiterate what Evan said, is that we are looking for speakers. We're looking for your stories. We want to hear them. They don't have to be AI related. You know, we are AI and software engineering and ethics, ethics, but ethics and AI. But you know, so we want to keep it kind of technical, but it doesn't have to be an LLM talk, for example, right? If you want to talk to me about XGBoost or vector similarity or something like that, I'm happy to listen to that stuff. So make that happen. We're going to talk today a little bit about what we call here the impossible intern, and why it's called that, what it's talked about, why it's called that, what it's talked about, and how we're kind of approaching that here inside of PMG. We'll definitely do that. What happens when Gemini Prefect, Graph of Thoughts, and a bunch of artists get together is kind of the subtitle for this talk. Like I said, I'm Brent. I'm a director of software engineering and AI here at PMG. My particular remit is looking at the creative insights. Creatives are what we call, what do we call them? They're the ads, right? And so what we're looking at is how we can leverage the performance data of the ads and also marry that up with some of the aesthetic information contained within an ad, right? Something about, I don't know, does LeBron James do better than Steph Curry in an ad or something like that? Who knows? So the setup for the impossible intern, right? A couple of months ago, Google asked PMG to leverage LLMs to create what they called an impossible ad. Could we create an ad that would be impossible to create without an LLM? This was going to be provided or presented at Cannes Lions, which is about a month ago or so, and it's Creative Week for the artists of the world. It's like the Oscars of creativity in the south of France. No, I did not get to go. You can blame that guy right there, because I'm going to blame him. I didn't ask him, but it would have been fantastic to go. So PMG answered the call. We assembled an ad. We presented an ad campaign. Basically, we presented it to various and sundry folks, got amazing feedback. It's actually going to turn into a campaign for one of our clients going into the future. It was very, very well received. We're kicking off some collaboration, deeper collaboration with Google, and it was fantastic. So that's what we presented. The impossible intern is what we did not show. So you're getting the second best option for tonight. So there we go. What is the impossible intern, right? This was kind of how it started. And this is the original concept. I'm just going to be kind of walking around for a little bit. This was the original concept that we had. Over here, we have like a bunch of different ideas. They could be copies, copy or images or text or something like that. We want to feed them into an LLM, basically anything in this cyan color, that's Gemini. Humans are, this color, and then PMG data or any data is the other color as it feeds in. And what we wanted to do is create a system where we could score each and every one of these assets against some objective criteria, take those scored assets, rank them somehow, magic happens, rank them somehow, and then use that ranked imagery and generate an idea and then go to market with it, right? The original thought was, let's just push go on Imagen and go straight to market with it, right? And so this was kind of the concept. We very quickly realized that, humans are going to have to be involved here at the end. But and to refine the images and stuff like that. But that's kind of what we were thinking about. And then down here, we've got a bunch of prompts that are going to be injected into it, et cetera, that are going to be running the show with this system. And this was the intern that we were trying to do. This is where it started. This is where it is. This is meant to be an eye chart. Don't worry about it. We're going to drill into the eye chart in a little bit, but this is kind of what it looks like now, how things are being executed. And because we heard earlier today, LLMs can be kind of expensive, we wanted to instrument our code a little bit and figure out how much these things cost. And we're spending 26 cents to generate one image, right? Which, when we were first talking about it, I was talking to the creative team and I said, hey guys, we got to slow down a little bit. It's going to be a little bit expensive. And they were like, whoa, what? And I'm like, yeah, it's going to cost $0.25. And they said, oh, that's fine. That's not a problem. So, but knowing that is pretty important. Yeah, it's fun to play with the really fun stuff, but like we heard just the speaker before, if we can kind of reduce our costs, that makes sense economically. And as we heard from the speaker before, there's actually some sustainability reasons to, lower cost probably means lower kilowatt hours being burned and stuff like that. So it was important to be able to do that. We're not going to talk about what this is, but if you're doing anything with LLMs, this was literally a one-line code change from something called OpenLit. LIT, OPEN, LIT. If you are a coder and are curious about it, just install that one line, get everything running, which is hard to do if you don't have Docker, and then you're good to go on that one. So the first thing we want to think about is, graph of thoughts, right? What is a graph of thought? How does a graph of thought work? There's a reference architecture for it, and this always just cracks me up. The bottom there, it says, this is the official implementation of graph of thoughts. I didn't realize that there was like a neutral third party that said you're the official and you're not the official. But basically, the way that this works, these guys, SPCL, I'm not sure who they are. They seem pretty smart though. They gave us this chart here. I know I'm way off camera and all that kind of stuff, but this chart here kind of starts with basic interactions with LLMs, and then it advances as we go. Basic interactions with LLMs is just zero-shot prompting, right? We basically just ask a question, we get an answer back, right? And that's Probably a lot of people have done that. I do it a lot as well, but it's just a fire and forget, one and done kind of a result. Researchers have discovered that if we, instead of doing one and done, if we can start to like assemble thoughts together, different prompts that do one thing together, we can actually build on the context, fill the context and of the interaction with the LLM and actually get to a better result in the end. One of the first approaches on this side, one of the first approaches was this chain of thought, which was just a very linear, start with your initial prompt, develop it, and you get your result. Then people started thinking, okay, tree of thought might be a way to do it, where we would try 3 or 4 different attempts to do something. Eventually something happens and we prune them and they go away. And then we start thinking about, well, that's multiple chains of thoughts, I'm sorry. Then we start thinking about a tree of thoughts where things will start to now branch out and feed into each other, pruning will happen, et cetera, et cetera. But if you notice, each of these things to the left, your left, the thoughts never converge on themselves, right? And so the graph of thought people started to design a system where you will now have thoughts starting to converge, and now you can start to think in terms of different thoughts collaborating with multiple different thoughts, and they all kind of combine to make something a little bit better. And that was the key innovation with this one, that we wanted to try to do, partially because it's kind of cool, it's a neat thought, but also because we felt like if we could do this, if we could combine all these different scores together, we're merging them together, then we're actually starting to get a little bit better performance out of the system. Is that kind of clear? Sort of clear? I'm cool about taking, short midterm questions if anybody has a short midterm question. So the key insight for this type of interaction is that LLMs will provide better responses when a prompt is mostly atomic, right? It just does one thing, one small thing. Consequentially to that key insight, the output of prompts can be the inputs to other prompts, plural, right? We can start to coalesce things. And when a prompt says, do this, and then do this other thing, that's a signal that maybe your prompt is doing more than one thing. And you could maybe, when you're designing your prompt, when you're a prompt engineer, I'm pointing at these guys and giving them a hard time because there are new hires cut right out of college, and I just got done spending a lot of time with them, and we've talked about all this stuff, including prompt engineering. So I'm going to be having a go at them all night. But anyway, when a prompt is saying do this and then do this and then do this, chances are you can maybe consider breaking it up into smaller thoughts and then re-architecting how you interface with the LLM. I'm not saying re-architect your software. Just think about how you're doing something with the LLM and go forward from there. Okay, so that's graph of thoughts. Gemini. What's Gemini? Well, I didn't anticipate the speaker that was right before me. It's an LLM, it's from Google. Most people don't know what Gemini is because everybody thinks about GPT or maybe Meta's Llama stuff or something like that, right? But Gemini's out there, and it's a thing that's out there. We, of course, use Gemini. We use Google's system here because Google asked us to do this. But there's also some other reasons to maybe think about different LLMs. And this is one that was kind of touched on by both prior speakers. This chart here comes from artificialanalysis.ai. I have no idea who they are, but they drew a nice plot here. And it shows on the x-axis how expensive per million tokens something is versus a neutral benchmark called quality. It's the general reasoning score or something like that. And you'll notice like way out here, GPT-4, Claude 3 Opus, those are really, really expensive, $30, $40, but they're also pretty high up in the thing. So over here, you've got Mistral, you've got GPT 3.5 Turbo, another Mixtral, a few other things, very, very cheap open source stuff, but also fairly poor performance. But maybe that's okay, as we learned just prior speaking, that as we're prototyping, as we're doing stuff, it might be okay for us to not have state-of-the-art performance, especially if we're not going to pay for it. Gemini, the one that we're using, 1.5 Flash, is this green bar right here, and it's pretty good. You know, it's not GPT 4.0 level, but it's also a couple of orders of, well, at least an order of magnitude cheaper than Gemini. And so that matters, right? Question? Oh.
GPT 4.0 mini.
Yeah. So the observation is GPT 4.0 mini. That was released just a day or two ago or something like that. That's not on this chart. So I don't know where it fits. But the point is they did that because they wanted to blunt Gemini 1.5 Flash, right? What you'll find is that over time, LLMs are going to be pushed up into this quadrant. They're going to be cheaper. They're going to be more performant. This is actually called the efficient frontier of where things are, but it's really neat for us because now we can make those design trade-offs as we're starting to do things. So there's nothing about what we're going to show that is strictly restricted to Gemini. It's just that's just where we are. You know, we could redo this and use OpenAI or something along those lines if we wanted to. These ones are all, yeah. So the question was, are these all large language models? I believe technically these are all large language models, yes. I don't know, is Mini a small language model? Okay, so Mini is a small language model, so that's a different, but it's still a generic, it's still a general purpose. Yeah, we're getting into some semantics here. But the point being is that some, you know, this thing here is like, what, 2 trillion tokens. Small language models aren't that, or not tokens, but parameters. Small language models are not that, right? There's trade-offs to be made, right? I just want to make this point here on this slide and then move on.
Question on the general ability index.
Yeah.
It goes to 110. All the use cases I looked at on a good day, maybe you get 95% accuracy.
Right. So this is, what's the, I don't know. This was just literally, I don't know who these guys are, but this is a chart that is representative of a lot of other studies that are out there. And this one was a good one. There's other things called the MMLU, which is a thing. And then there's like math score and there's this score and that kind of score. This is just a general one. Okay, next one. Gemini, and I'm not at all a Google employee, but you know, Gemini and Google Cloud make it easy to use our content, right? Our PDFs, our images, our videos. That actually is important for us because well, I'm not going to go there, but videos are very important for us. Google Cloud makes that very easy. They try to present a garden for us to play in. I don't want to say a walled garden, but a garden for us to have access to all of our data. And our content, our data is how we build the moat. This is something I will die on this hill. Anybody can prompt. Only PMG has PMG's data, and that's our key differentiator. That's probably true wherever you work. And I literally will die on that hill. I feel very strongly about that. Anyway, so Google makes it easy to use our data, which is fantastic. So we've talked about the guy. I'm going to show you the impossible intern. I'm going to do a very quick demo here. So we'll see how demos go. Those are always fun. And we'll see what's going on. First, what I wanted to say, I didn't really make the point, but we had this concept of a creative brief being injected into the demo. And this is one of our creative briefs. This is what a creative brief looks like. And basically it's just how we interact with Best Western, right? And it just basically, the artists will use this to do something with our creative brief. So that's what? This is the input. This is the input. Someone did this, and this is what we give to our creative team to do stuff, right? And so I've got, let me kill this and let's start it up again. And so here is the web app that's running. It takes a little bit of time. Don't go to production with Streamlit. Not a good idea, but it works. We're going to upload the creative brief once I get to it. And now what is going to happen is we've sent it off to Gemini. Gemini's parsing it out, and we've asked it to do, to analyze that and create another prompt from it for us to do the scoring with, right? And so when it comes back, hopefully it'll come back soon, it basically summarizes the brief, and it basically says the main theme is life's a trip. I never told you'll see what the original prompt is. Nothing in the original prompt mentioned Best Western, but life's a trip. The main theme of the brief is that life's a journey, and it describes all of that. And then it tries to extract categories for sub scores when we're scoring the thing: target audience, brand positioning, visual style, messaging, and a call to action, right? And it generates all of that. And then it also generates some nerdy JSON stuff in order to make the prompts a little bit more. We're all nerds here. Most of us are nerds here. So it makes the prompts, I'm doing a lot of handoff with JSON documents in order to make sure that I can actually write software against them. So that's what that does. The next step is to score some assets. I'm going to browse some files. I'm going to select, I got to set this down, sorry. I'm going to select a few assets to score. We're going to go out, generate the scores of these things. So now what's happened behind the scenes is that Gemini has created this new prompt, the scoring prompt, and I'm using that exact same scoring prompt against all of these assets at the same time, right? So each of these assets are going to be evaluated identically against as far as Gemini is concerned, right? So now we have, I don't want to say it's a ground truth, but at least it's a consistent truth for how these assets work. And right here's one of them that says kids on a hike. It's a group of children dressed in various outfits. Value, this main score, how well does it score against the main brief? -1. That's the worst one that's out there. This image looks like this. If somebody wants to say which one of these is me, you can answer that question when many years ago. And so that was this one. It does not do a very good job against the main brief. This next one, family beach vacation, value of 0.5. It's got a category score of 0.75, brand positioning about 0.25, and then it gives you some textual information about all that stuff. But the point is now we've got content that we can use internally to give to our creative team when we're designing stuff to say, this is how these assets work against each other. That's what this one looks like. And then this last one is an Athleta video. And it actually, the main theme is find your moment. And for some reason, and this is why LLMs are scary, it thinks it does a really good job, 1.0, against the creative brief for Best Western. That's probably a bug somewhere because that should not have scored that high. And in fact, these are all 1.0 except for this call to action thing at the bottom. So it could be, this is the first, of course, it's a live demo. This is the first time it's looked like this. Maybe Gemini changed its thing in the background or something like that. So then once we get that all done, we can now go to ideating an asset, and it basically will say, I can type in whatever prompt I want into here, and I'm going to say I want a realistic wide-angle photo, family arriving at a lodge, blah, blah, blah. And then I can ideate, and what's going to happen is now the intern is going to generate this thing just based on all the information that we've gathered, and we've filled in the context. We've scored these assets. We know what some positive things are. We know what some negative things are. And we're going to try to add content to the full prompt, which we just copied from here, but we're going to add, some keywords from the brief that are important in the brief, and we're going to add some keywords that are important from the scored assets above and beyond. And this is what it came up with, right? This was the mountain lodge that it came up with. And then at the bottom of this, it goes off and it scores it, and it thinks it scores a 0.8 against the creative brief and everything else, right? And so if I gave it more positive images, more positive examples, it would maybe, the hope is that it would do a better job next time when it goes on. So that's the web-based version of the intern. Does everybody kind of follow what we did there? And I only scored 3 assets here, right? Right. So the observation, the question was, how many assets did we score? Only 3 in this run. But the observation is we have millions of assets. And yes, we do, right? And so we can start to leverage those millions of assets to build our moat to hopefully generate really good ideas for our humans to iterate on. And that's the key concept here. We can also do this automatically, right? What a great segue. What a great segue. Save our creative. Dan. That's exactly correct. You know, how do we automate this? How do we save a step here and make that go, right? But first, a little bit of code, just a little bit of code here, right? This is how do we summarize the brief and generate the scoring prompt. Basically, there's this function here called summarize brief thought. It goes off and it interacts. It summarize brief thought. That thing returns a summarized brief. The summarized brief goes now into generating the scoring prompt for the next thing. And so we're kind of building a chain of events that kind of go together, right? This is the kind of one step in the graph that actually that we're building up as we go. But this is just one step in that graph. And I just kind of wanted to make that point. The scoring prompt comes from an LLM as well. Yes, we're generating a scoring prompt. That's a great question. The question is where did the scoring prompt come from? There is a prompt that summarizes the brief, and then there is a generated scoring prompt that takes the brief and scores it against it, right? So we're using parametric prompting here, where we've got a generic prompt and we're dropping a context in, and that generic prompt you'll see in just a little bit here that will now generate the prompts that we're really going to use underneath the covers. See that chain? We'll get to that in a second. Summarize brief thought. This is where the actual interaction with the LLM goes, and I want to show this for a real reason. There's this thing called @task, but otherwise it's just a Python function here with the responses stuff. That's where it goes out and interacts with the LLM. I got one of these. I can use this. It goes out. It makes sure that we're being responsible in some sense by configuring the LLM to say, don't do bad things. That's what these safety settings are, et cetera. It does a couple of things, and then it just basically returns the summarized brief, which is just text. It's just a prompt, right? That generic prompt that we're generating with is this bad boy right here. The important parts is, we have to supplicate ourselves to the gods of LLMs and basically say, you are an advertising expert and executive and an expert at summarizing creative briefs. Apparently that's a thing, right? I highlighted this because we're going to generate a prompt that is used to both generate new ideas and to evaluate the quality of existing ideas. That might be 2 thoughts in one. So, maybe I'm violating a rule here that I just told you guys don't to violate, but that's possible. Then there's a bunch of stuff. And then back here, I just basically say, make sure we get the format, which summarize the brief as follows, give me a main theme, and give me 5 categories around there, right? So that's the parametric prompt. I can drop any creative brief into this prompt and it's gonna work, right? I'm gonna get a Best Western specific. I'm going to get any of our other client specific prompts that we get out there. Right. So the observation there, which was a good one, is the LLMs are not maintaining a state. So if I were to, with the exact same creative brief, even though I've turned down my temperature really low and I've tried to make it as consistent as possible, every time I do it, I will get a different scoring prompt out or a different summarized brief out of this. So what we can do though, is since it's just returning text to us, we can start the process from just there. If we find a summarized brief that we want to apply to the millions of our assets, we would just use that. And that's our consistent thing for there. But you're absolutely right. If we run it twice, it will come back with something different. Real quick question.
Could you talk more about the evaluating quality?
Let's get to that kind of near the end, because I do get to that. The question is, you know, how do we actually evaluate quality? How do we spell quality? Is it spelled with a K? What is the objective truth around quality? How can we reduce the time to make it go faster, right? Because it did take a while, right? And you're absolutely right. We're getting to that. Trust me, we are, right? Because it did take a while, right? The generate scoring prompt, this is the prompt that is meant to generate the scoring prompt. This is pretty complicated. It talks about, you know, take the summarized asset, take a couple of pydantic models for the JSON that comes in, and then be able to, you know, generate the scoring prompt and the scores based on that, right? So the combination of the prior slide and this slide kind of get combined together to make a prompt so that we're pretty sure that we're going to get JSON back that is scored against a consistent truth. And this is why I'm saying consistent truth. It's not objective truth. The question was, you know, how do we evaluate quality? Well, it's art, right? You know, when you see it, right? How do we as humans do that? I don't know, right? And so there's something there, right? Generating a prompt basically looks like this. This is kind of a zoom in. We get the creative brief at top. We go to Gemini. We get a summarized brief. We get the JSON schema and some examples JSON to come in. We generate the scoring prompt. They both come together, and out the back end, we get the generated prompt, right? So this is a fairly complicated little linear graph of the way things go. What exactly is, what is it? Okay, so what I've done from the pydantic model. So pydantic is a library in Python that allows me to model concepts, data objects in Python, and then serialize those to JSON and JSON schema, right? So here, this is the asset, which is the thing I'm going to score. The asset has a title, it's got a description, it's got a main score, and then it's got a list of category scores. And then the category scores, every score is one of these things. And so when I say generate the schema, this template, that's exactly this template, just generates that schema for me. So I don't have to deal with JSON because I always forget a curly brace. But Python, they don't have curly braces, so it works pretty well. So that's how that works. And then eye charts are not meant to, this is just for completeness, right? Here's the example JSON schema, and this is literally the prompt that gets sent in, and it's just a JSON document that goes off, right? And the LLMs are smart enough to say, oh, I know exactly what to do with this JSON document. And somewhere in here is the actual schema embedded as well. So that's pretty amazing, right? But, you know, here we go, right? You know, yo dog, I heard you like prompting, so I made you a prompt to prompt so that you can prompt when you're prompting, right? And so, you know, that's where we're at with this one. And then prefect. This kind of goes to what is prefect, how do we automate this? How do we make things go a little bit faster, et cetera, et cetera. Prefect is a workflow orchestration framework for building resilient data pipelines in Python. They say it is the easiest way to transform any Python function into a unit of work, blah, 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 blah. If you've worked with things like Airflow or Dagster or any of those DAG-oriented workflow orchestration tools, this is one of them, right? This came out of some people who did not like the way Airflow worked, so they came up with Prefect. And I just happen to like Prefect, so this is what I'm using. Again, I don't work for Prefect, I work for PMG. If we want to use Airflow, we can do that. don't do, no, you can do that. Or any of those other workflow orchestration tools. We can totally do it. I did highlight the easiest part because I want to, that's foreshadowing. And so it'll come out. How big should a task be, right? Prefect encourages small tasks. You know, they should have a single logical step in your workflow. This kind of sounds a little bit like graph of thoughts, right? Where thoughts should be atomic, right? And so when I did this, I was like, hey, you know what? This is actually kind of a good marry. We can kind of go forward with both of those. Prefect like small, graph of thoughts like small, do one thing, do it well. It also contains task failures. And we're going to talk about that here in a second. Demo of Prefect. I'm not going to demo that because we're running a little bit long, and it's literally just a command line thing that I'm going to hit enter on, and you see a bunch of text scroll, and it's just, it doesn't make for a good demo, so I'm not going to. But when it gets done, if we were to execute it, this would be kind of the main flow of Prefect. This is the intern right here, and you can see we've got down here, get files from the creative dir directory. It returns 2 lists of MIME types and file objects. We have the same summarized brief thought that we had before. It returns a summarized brief, but in this case, we're submitting it. We're not just directly calling the function. We're using the submit function. There's this other one, generate scoring prompt thought, right? We're submitting that as well. We're passing in the summarized brief into that. Again, the DAG, we're starting to show the workflow as it goes forth. In the case of the scoring asset thought, that is a map. It's not a submit. If you're a Python person, you can think of map. You kind of know what map does. It operates over an iterable, and it does things, right, for you. And that's what those maps are doing. And the mapping of the scored asset thought, it returns something called scored asset futures, and those futures are passed into the filter asset function, right? These are all under the covers, simply functions in Python. Some idioms here, map and submit is how you tell Prefect to manage your workflow. And then futures are basically promises of the future. Async IO or Dask, if you're a parallel programmer or something along those lines, that's what these futures are. It's the same stuff. It's just not very hard. Prefect just handles it for you. When another idiom, we've seen this slide before, score asset thought, right? I think we've seen this one. It is a normal function, but it has this task decorator on top of it. And it has retries equals 3, retry delays in seconds. So it's going to retry 3 times with a 5-second delay if this function has a failure. And this function might have a failure because when we're trying to parse this, validate this JSON, it might not, the LLM might have, because LLMs are poopy headed sometimes, it might return back something that is not JSON, and then it will throw an exception. And in which case, Prefect knows exactly what to do with this. Okay. All right. So now here we are, we're back at this, right? This is the overflow. We're going to zoom into it, but this is the Prefect execution DAG that we did, right? On the far left-hand side, we've got get files. It goes out and it gets the files. Well, let me go back to here. I want to say every green bar is the CPU is active, the task is active. The longer green bars are LLM interactions. The shorter ones are probably local things that we did. And so that's kind of the way you see this. We come here, we summarize the brief thought. We get out of here the summarized brief. The summarized brief comes down here into generate scoring prompt, right? So that this line here is literally what those bubbles, those circled bubbles that we were showing a little bit earlier were. That's what that line is. You can see that the get files method feeds out here to the right-hand side of the screen, and that thing there, along with the output of the scoring prompt, feeds into the score asset thoughts, all of those score asset thoughts. And these are all now executing in parallel, right? And so that's one way that we can make things go faster, right? We can start to execute things in parallel. And while the compute cycles is the same, at least we're getting our results back faster. So that's one thing that Prefect did for me. I didn't have to tell Prefect that I've got to execute 7 of these things. It knew because it looked at those iterables from earlier and it said, oh, I've got 7 things in these lists. I just know I can schedule these things, 7 of them at once, right? This one here, score asset thought 0, it's a lot longer than the other ones. The other ones, score asset thought 1, it scores the asset, it gets the scored asset response, and then it gets the scored asset JSON. This one here, scored asset response, and then finally the scored asset JSON. This is Prefect getting an exception. The first time it got the response back, it was not JSON. It tried to validate it. The exception got thrown. So Prefect just said, okay, I'm just going to try it again. And sure enough, it covered it for us, right? And so now that interaction with the LLM is a little bit more resilient, a little bit more what we care about as engineers when we're trying to design a system. And that, I love this example, and this is why this example was in this slide deck, to literally point that out. The rest of it is looking at negative thoughts and positive thoughts and modifying the generation prompt based on the brief and then generating the image and doing all that stuff, right? That's what all that stuff is. And then finally at the end, we generate the image, we score the image that we generate, and then we just persist it as time goes out there. So that's kind of the entire execution flow. This is the graph of thoughts for the intern. So it's not exactly the same picture that we started with, but this one here actually is executable, and I like that. The final generated image looks like this. The title is a family gathering in a hotel room. The main score is a value of 0.5. This is actually a pretty underwhelming image, right? I mean, it's like, oh, Brent, you've been talking 45 minutes and you're showing us this. I get it, trust me. That's why we did this image here, right? This is another run, and this is a main score of 0.8 with pretty good category scores as it goes on there, right? So what did we learn from all of this? Sorry, sir. You're just, okay, good feedback. Good visual feedback, right? Yeah, so what did we learn from all this, right? Parametric prompting for the win, right? We can create a base prompt and add content and let the LLM figure out how to specialize that prompt as we go forth. That allows us to have we don't have to think about it every time. We can just do it, right? And the LLM is just going to do it for us, right? Anyone can prompt, only we have our data. That helps us build a moat. We learned that graph of thoughts can be pretty hard. The thoughts have to be stitched together somehow, and that JSON is not a guaranteed output, right? This is a design and architecture problem. It's not a prompt engineering problem. It's not an LLM problem. It's a software problem. And what that means, frameworks like Prefect helps, but it also means that when we hear things like really smart people that I totally respect say the programming language of the future is English, that might be true, but we still have to think about what we're asking that English to design, what that English is going to try to architect. When I say we, I'm thinking software engineers and designers. We have to think in terms of how do we actually assemble a system. The LLMs today, near future, probably aren't going to make that go away. Point being is, if you're a software engineer, your job is probably pretty safe. Automating GenAI is not all of that. The final images can be pretty underwhelming. I maybe could do a better job of writing prompts and architecting the flow. Maybe I could, but could I? No, it's the LLM that's wrong, right? What we tested, though, more seriously is, can an LLM do these things? Consume upfront data? Yes, we can consume our creative brief. Can we mix it all together? Yes, we can mix it together with scoring and prompting and all that kind of stuff. Can it generate a final let's go to market asset automatically? No, it really can't. We're just not there yet. Even when Google releases or when we use Midjourney or any of that stuff, we're not going to go straight to market yet with generating an image just from scratch, kind of like what we're trying to do here. It's just not going to happen. That said, hallucinations are a thing. The creative process might be where hallucinations are actually an asset to what we're trying to do here, right? And that's a thought to think about. But let's see. So that's that. There's this quote here. It's AI until you trust it, and then it's automation. Right now, I do not trust it. I can't do that yet. And so if it's not AI, if it's not automation, what is it? What can we do with this? Well, it's augmentation, right? What we really want, this guy, I have no idea who Carnage for Life 4 at Mass.2 is, but this quote really resonated with me, right? There's a big difference between tech as augmentation versus automation. Augmentation, think Excel and accountants, think of what Excel did for the profession of accountancy. Benefits workers, while automation, think traffic lights versus traffic wardens, benefits capital, right? We don't have traffic wardens anymore. It's all traffic lights. So now that's a cost-saving metric. LLMs are controversial because the tech is best at augmentation, but is being sold as by lots of vendors as automation, right? We can automate this, we can automate that, we can automate this other stuff, and all these jobs just go away. And that's beneficial for CFOs, but it's kind of employee unfriendly. And I like this. I like this observation, right? But we were always here, right? The very last end of the original slide was the human refining as we go. We can take these millions of assets that we have, we can generate some prompts with them. We can get content that we can now give to our creative team, and the creative team can start to ideate on those refined images, and they've been generated according to guidelines that we might trust, we think that, this is a good image, this is a bad image, et cetera, right? There is still the open question as, how do you define quality? What is the objective ground truth of good versus bad? From an artistic, aesthetic point of view, I can't answer that. But from a performance point of view in the ad space, not only do we have millions of creative assets, we also have millions of bits of performance data that we can relate to those creative assets. So if we start to extend the intern to not only take in the creative brief, but now starting to reach into our databases and saying, hey, you know what, this proposed asset worked, it had this kind of performance, had a click-through rate of X and a video completion rate of Y. We can now start to create a system. We can start to think about a system that when we start to ideate around that, we can start to say things like, and create a image, an ad that will have a click-through rate with this audience on this platform of X, right? And then that is how we can start to get to a definition of quality, a performance-based definition of quality, as opposed to an aesthetic-based definition of quality. Boom. Do we have any questions? Yeah.
Benchmark the output from the AI, the final digital asset and the image, benchmark it with the creative director. What they come out of the creative director?
Not yet. No, this is still pretty early. I'm going to be talking to our creative director in the next week or two about this concept to do exactly that. Basically, can we bring in human evaluators against this sort of stuff and determine if the images that are being generated are indeed actually useful to them, and that's what we want to do. I did also say when I kind of addressed this. How do you speed up stuff, right? When I started this, there was an LLM called Google Gemini Pro 1.5. They released Google Gemini Flash 1.5, and my LLM interaction times decreased by a factor of 2, right? And so the big providers are going to be making things a little bit faster. So that's another way. Any other questions?
Because I come from that business. So I can see this can definitely enhance their creative part, the productivity in the big time. But when you pass down some of the asset generated from the AI to the creative staff, what their feedback about this?
That they're the same sort of thing that we saw earlier. You know, these are pretty underwhelming, right? The images are pretty underwhelming. So then the question is okay, how can we do this better? Can we do this better? Is this worth investing in? I think it is. I think that there are parts here that will actually help us, but maybe generating that asset is not the part that helps us. Maybe scoring of all the assets is the big unlock here, but maybe not the generation part, right? Yes, sir.
So the output, the kind of the animated image, could have all the data elements that should drive the click-throughs. Like you've got a family of 3 people overlooking a cliff or whatever, and so it's got all the elements, kind of like the song may have had a lot of words in it, but it wasn't a #1 song. So it might be useful like as a storyboard,
Right.
to get the clicks that you want to get, but not as a go-to-market image.
Yeah. The go-to-market of this image, I mean, it's actually not a bad image. I wouldn't build. Yeah, this one for sure. I would not build a marketing campaign around it. Probably not. Maybe, but probably not. But could I give this, once it's been generated with all of our performance data and stuff like that, once all of that has been injected into the LLM's context, then the creative team now has an additional tool in their belt to generate real versions, right? Because these are just going to be ideas that augment their creative side, but they don't have to now think as hard as they did about all the performance data because this is already there. And that's an efficiency win for us, right? Someday I could see where we would generate 5 or 6 of these in sort of a sequence, and that becomes a literal storyboard for video generation. Maybe not, right? But that's going to happen, and I hope it happens here at some point. Yes, sir.
You can probably put a human in the loop at the point of prompt iteration. And then just start off with a bunch of prompts and results are good or classified as good by like a specific, whoever's reviewing it, maybe it's creative. And then like see what's exclusive to those specific prompts and then iterate with those.
So the observation is, can we in the prompt generation process, can we actually iterate? Can we put humans in the loop to make the prompts a little bit better? And I think there's a lot of value in that thought there, which is why I kind of think for a little bit, the web interface is better because the web interface allows us to step into those points and evaluate them. And it would be a web app. We can do whatever we want. So then we can start to collect the good parts of the prompts and the bad parts of the prompts. Once we get everything kind of put together, then we could let Prefect go do its thing with its finely, highly tuned, human in the loop, validated prompting and stuff like that. I honestly think that's probably where this is going to go, something along those lines, at least until we can start to trust it, right? It's not automation yet. Thoughts? Questions?
Yep. So I was thinking like, why in step 1 and between step 2, why didn't you did 1 shot or 5 shot training of what is good image, what is bad image, rather than just giving it the main asset and then corresponding asset and just asking LLM to give the answer?
Why wouldn't we have done put a chain of thought up at the front? Yeah.
There is so much work, which is really good.
Right.
But when I first thought of the solution, I was like, okay, you're probably gonna give 5 examples or 2 examples of good images and bad
or bad. Well, that's kind of what we wanted to do with the ranking on the scoring, is to say let the LLM determine what the good or the bad is. What we haven't done is gone to our creative team and said that the creative team has human labeled this is a good image and this is a bad image. That would be a great next step for sure, right? This is really early prototype, so a lot of those, and I'm not picking on you, but a lot of those, why haven't you done X? Just because we just haven't had time to do it yet. Yeah.
The LLM can do a very good job just scoring, understand the brief and score the asset.
Yep.
The challenge is when you get down to the image generation, based on all the information you have.
Right.
I wonder, you said you used the Gemini, the Google Gemini. Have you compared that part of the function with the Midjourney?
Not yet. I don't, Midjourney, no, actually I have. Midjourney does not have an API to use, but I have extracted the prompt and just dropped it into Midjourney. And that does they're different LLMs are different beasts, right? And it's a manual process, but maybe that's the right answer, right? Can I do this with DALL-E? And yes, OpenAI has an SDK. And so I can use Gemini for whatever reason up front and then use DALL-E on the back end. All that is mix and match. I just want the best answer. I don't really care what the answer is. I want the best answer for the best price. That's a couple of things to trade off in there, but yeah. Any other questions?
We can do one more question.
One more question.
Here we go.
Oh,
Thank you. So have you tried, or do you think it'll be helpful this was all like you got a prompt, you generated an answer, and then you passed it on along. Would it be beneficial to use like a chat where the LLM has a history of the previous conversation?
Yeah. Can we use a chat interface and build up the context as we go? Can you do, here's this, score it. Oh, I don't like this very well. Do it again. Yeah, that's totally doable. And that's a very good idea. I did not obviously do that. I wanted to focus just on the atomic thoughts as we went, but clearly, the chat interface puts that human in the loop just explicitly. And I think that's, we could use the chat interface to zero in on the automatable prompts and then turn it over to Prefect or whatever our workflow orchestration engine is to do exactly that. Yeah. All right. I think that's the last question. I want to say thank you, everybody. I came in from Austin to give this talk, and I'm very happy to.
All right. Thank you, Brent. Man, shout out to Brent making us look good up here, man. He gave hell of a talk. Before we wrap up, I want to welcome up Yashwant. He's a former speaker here. He's going to talk a bit about a program that he's got for everybody here. So if you're interested, sign up and we'll hear a bit more here. Yashwant, everybody.
Muthuswamy. I was the speaker last month. And for those of you who were here last month, you might remember me talking about a course. And at that time, the course details were not finalized. That has changed. The course details have been finalized since then. My course is going to start on August 3rd. And we will see the flyer for the course momentarily as Evan gets it up on Zoom. The course is called Generative AI for the Rest of Us. It is designed for business leaders, sales, marketing professionals, and any non-technical professional who has to be dealing with AI on a daily basis sometimes, who needs to understand the value proposition, who needs to understand the use cases and application areas and the powers and limitations of the technology, but is not necessarily interested in the technical details. If you're going to come to this course looking to train large language models using Python, you're going to be very disappointed. There is no Python. There is no math background expected or required. No technical background is required. But you will leave with a solid understanding of what AI and GenAI are all about, and you will get practical, actionable, and insightful information, lots of hands-on exercises. It is not confirmed yet, but hopefully each one of the students will leave with a chat bot that they have built themselves. No code. And there's going to be homework in every session. No exams, but there's going to be an interactive quiz in every session to make sure nobody's falling asleep in the middle of the session. And Evan doesn't know this yet, but for people who are here, I am offering a promotion code. So PMG 10. If you type that at checkout, you will get 10% off the fees. But this promotion is valid only until next Tuesday, a week from the meeting, PMG 10. And if you're interested, please scan the QR code. And I hope to see some of you in class. Thanks, Evan. By the way, any questions on this course? Yes. Thanks for that question. It is going to be held in person, live, at Divergence Academy, which is on Midway Road, just half a mile south of Beltline Road. On Saturdays, 1:30 p.m. to 4:30 p.m. I am a recovering Zoom user, so no online version, at least for now. This is going to be in person. You have to show up there and you have to be in class. And don't take my word for how good this course is. If you scan the QR code, you will get to my website where there are student video testimonials and written feedback from the 33 students who have taken this course so far. This is the third cohort of the course. It starts on August 3rd. Any other questions? Okay. Thanks, Evan.
Absolutely. Thank you. All right. We're at the end. But before the end, I really and truly want to thank you all for coming. We appreciate your presence. Without you all here, what's the point? Am I right? So hopefully you got something out of it. I want to put one more pitch out for PMG. If you are interested in learning more, find me. Happy to give you a little bit more information here. And I know I didn't do much of introduction to PMG, but I'll channel my best Vlad at this moment. So if y'all have been here before, I'm stealing a lot of this from him. But PMG is a fake advertising agency. We are a technology company. If you don't know Vlad, that's much funnier if you know him. If you don't know him, then it's not going to work. But there's going to be one more thing I'm going to channel from Vlad. So if you've been here before, you know what to expect. But all of our security guards that you walk by on your way in here, I'm not playing the game with y'all, have been given explicit instructions. And nobody will be allowed to leave here unless they follow these instructions. I'm not playing around with y'all right now, okay? Now, what we need you to do is pull out your phones. Go ahead. Don't be shy. Pull out your phones. Open up your camera. Find a friend. Meet somebody new. Take a picture and post it on your favorite social media account and tell everybody there how much fun you had, how insightful this was, and how you're coming back next month. Yes, we are doing these monthly, and we want you back the next time, and that will be your ticket to leave. They've been given explicit instructions. All right, thank you all, everybody. Appreciate your patience. Enjoy the beverages. Have a snack before you go. Thank you all. Thank you very much.